Polygons. What is polygon? Polygons are two-dimensional figure shapes bounded by straight line edge with vertices and corner. So when we are talking about polygon, they are just plain shape, two-dimensional shapes having straight line that is bounded by straight line. The boundary is just straight line, no curve. That is what makes them polygon. And every polygon is going to have vertex, and vertex is a point at which two edge is meeting. Vertex is also known as corner. So, and the plural form of vertex is vertices. Since polygons is having multiple edge, so we are going to have multiple vertices. Now we have types of polygon. The first types of polygon is regular polygons. Now regular polygons are polygons with equal edges, equal sides, and interior angles. When we have a polygon in which all the interior angles, don't forget interior angles is angle inside. Now when all the interior angles are the same, we have a regular polygon. And automatically, if the interior angles are equal, it means that the edges will also be equal. The first type of regular polygon is equilateral triangle. Don't forget, equilateral triangle is having equal sides. The three sides are the same, and the three interior angles are 60-60 degrees. So it makes it a regular polygon. The next one is square. We have here square is having the same sides. So each interior angles at each vertex is 90-90 degree. Then we also have regular pentagon. Any shape other than square that is having more than 4 sides upward, we are going to have regular pentagon, regular hexagon. We have on decagon is having 11 sides. So 11-sided polygon is known as on decagon. And these polygon that we are seeing, they are not just polygon, they are regular polygon. So we have regular on decagon, dodecagon, that's 12, tridecagon, 13, and up to 20. 20-sided polygon is known as icosagon. So that is regular polygon. Equal interior angles, equal size. We cannot compare it with a rhombus. A rhombus is a quadrilateral that is having equal size, but the interior angles are not equal. So rhombus is not qualified to be a regular polygon, even if it is having equal size. The next one is irregular polygon. Irregular polygon, they are polygons with unequal interior angles and sides. When you have a polygon that is having unequal interior angles and sides, so we have irregular polygon. The first one here is we have a rhombus, even though the sides are the same, but the interior angles are different, so it forms irregular polygon. The same thing with all these shapes that we have here, they are all irregular polygon. This is a trapezium over here. This is 1, 2, 3, 4, 5. This is irregular pentagon here. This is a scalene triangle that we have here. So just count the number of sides. 1, 2, 3, 4. Let's go again. 1, 2, 3, 4, 5. So this is irregular pentagon. So if you want to count the number of sides of this polygon, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have irregular dodecagon. All these shapes, they are irregular polygons. So we have the examples here. So I have concave polygons. So when polygon is concave, what does it imply? It means that none of its interior angles is greater than 180, which means that none of its interior angles is a reflex angle. So if you look at all these shapes, you discover that all the interior angles, the first one being kite, the interior angles here is not more than 180. We have obtuse angle here, obtuse angle here. So we don't have a reflex interior angles here. Any polygon that is not having a reflex interior angle, that is the interior angles is not greater than 180 degree, we call such polygon concave polygon. And you can also see that all these polygons are concave polygon. The next type of polygon is convex polygon. Convex polygon. Now for convex polygon, the interior angles, at least one out of its interior angles will be a reflex angle, which means that it's going to be greater than 180 degree. So we have this shape over here. we have this shape over here. We have this shape that looks like kite. But observe something here. You discover that this angle that we have over here is a reflex angle. When I was explaining reflex angle, now this angle that we have at this vertex here is also a reflex angle. This one is having two reflex angle here, one here, another one here. This one is just having one. We have a reflex angle here. This one is also having one, a reflex angle. This one is having one. So all these shapes, because they have a reflex interior angle, so they are categorized under convex polygon. The next polygon which we are going to talk about is triangle. And what is triangle? We have three-sided polygon are called triangle. So triangle is going to have three corners, which is vertices, and they are going to have three interior angles and exterior angles. Don't forget interior angles, angle inside, exterior angles, outside angles. So we are going to look at it, the meaning of interior and exterior. So these are examples of triangle that we have here. So when we have polygon with three sides, they are known as triangles. Now we have types of triangle. The first type of triangle is a special one, which is equilateral triangle. Equilateral triangle is also known as equal angle triangle. So equilateral triangle, which is a concave polygon and also regular polygon. Now all its sides are equal. When the three sides of triangle is equal, we call the triangle equilateral triangle. The same way the interior angles will also be equal, and the same way exterior angle will be equal. Exterior angle will be 120 degree each, that is 180 minus 60 degree, and interior angles will be 60 degree each, because the sum of interior angles of a triangle, which we are still going to look at, is 180 degrees. So this one will be 60 degree. That is equilateral triangle. And how do you know equilateral triangle when you are given a question? Most time when you see this symbol, you have three strokes on each side of a triangle. Is telling you that if it is just a single stroke each, it's telling you that the sides are the same. So we have equilateral triangle. Or if you are not given stroke and you look at the value of the sides in the question and they are the same, it's telling you that this is equilateral triangle. So every equilateral triangle is going to have 60 degrees as interior angles. Now we also have isosceles triangle. Iso means equal. We have isosceles, we have isomerism, we have isotopy. So iso means equal. Now we have isosceles triangle. For isosceles triangle, two sides are equal. When we have triangle in which two sides are equal, we call the name of that triangle isosceles triangle. Two angles formed by the two equal sides with the third side are equal. So which means that if two sides are equal, any angle that is formed by the two sides with the third side, the angle will be the same. Let's look at this isosceles triangle. Now we have this side, there is a stroke on it, and we also have this side, there's another stroke on it, the same stroke, a single stroke. So which means that this side is equals to this side, and this side form an angle with the third side here, which is A. This side form an angle with the third side here, which is B. So it now means that A will be the same thing as B. So that is what it's saying. A is equals to B and A is equals to B, not equals to C. So A and B are the same. That is why this triangle is called isosceles triangle. This side is also equals to this side. Isosceles triangle. Now, to the amazing type of triangle, which is right angle triangle, a very special one. Now, for right angle triangle, one interior angle is 90 degrees. When you have a triangle in which out of the angle we have right angle, which is 90 degrees. So which means that one interior angle will be 90 degrees. So the name of that triangle will be right angle triangle, since we have right angle in it. So we are going to have right angle triangle. So A here is equals to 90 degrees. So that is why we call this triangle right angle triangle. This right angle triangle because A is equals to 90 degrees and B is not equals to C. What if B is equals to C? What will be the name of this triangle? We call it right isosceles triangle. In a case whereby we have a right angle triangle and the other angles are the same, 45 degrees, so we call the name of that triangle right angle isosceles triangle or right isosceles triangle. So here we know that A is equals to what? A is equals to 90 degree and B is equals to C. For B to be equals to C, B here must be 45 degree and C is also 45 degree. So we cannot have right isosceles triangle. The last type, which is scalene triangle. For scalene triangle, none of its sides are equal. So none of the sides are equal and none of its interior angles nor exterior angle equal. So the name of that triangle is called a scalene triangle. And we can as well have a triangle that is right angle at the same time scalene triangle. So that is right scalene triangle. So let's learn interior and exterior angles. Let's have a polygon, a regular one as shown. This polygon is 5-sided polygon, which is regular pentagon. So the interior angles, the first one, let's label it A. The next one B, the next one C, D, E. Now these angles that is formed at this vertex are called interior angles. So let's form exterior angles. To form exterior angles, we have to extend each line here. We have to extend it further. So we have A, B, C, D, and E as our interior angle. So let's extend it. We extend this one. So any angle that is formed by this side with the extended line here is called exterior angles. And let's label it A. For this one, let's label it B. And for this one, let's label it C. For this one, let's label it D. And for this one, let's label it E. So we have interior and exterior angles. Interior angles are labeled with small letter and exterior angles are labeled with capital letter. Interior angles are denoted by just a stroke and exterior angles are denoted by filled color. Just observe something here. Let's quickly observe something here. So this is our exterior angles. Now, to the observation, A interior plus exterior, you see that it forms on a straight line. And what is the sum of angles on a straight line? Sum of angles on a straight line is equals to 180 degrees. So we have this A plus this A, capital letter A. So is equals to 180. Now if you look at B as well, so which means that when you add interior angles plus the exterior angles, you will get 180 degree. Interior plus exterior, sum of a pair of interior and exterior for any n-sided polygon. Sum of the pair of interior and exterior angles of any n-sided polygon is equals to 180 degrees. So here we can see that A plus A is equals to 180 degree and B plus B is equals to 180 degree. The same thing with C plus C, which is equals to 180 degree, and D plus D, which is equals to 180 degree. E plus E is equals to 180 degree. Now let's have a triangle as shown. Now if you look at this triangle very well, ABC is interior angles and capital letter ABC is also what? Exterior angle. And we can also verify that when you add A plus A, we still get 180 degree. The same thing with B plus B, we get 180, and C plus C is equals to 180 degree. Let's see how to find the sum of the interior angles of any polygon using triangle. Now we have a triangle as shown, and if you clearly observe this diagram, you see that this side is having 3 arrows, this side is having a single arrow, and this one is having double arrow. And we've extended this line in order to make provision for interior angles and exterior angles. So let's fix the interior angles and let's label it. Now this one is A, this one is B, this one is C. Now let's fix the exterior angles. For exterior angles, let's call this one A, let's call this one B, and let's call this one C. Now, in order to prove this, since we are doing geometry, now we can have a parallel lines. So let's draw some parallel lines here. The first parallel line, let's draw it here. Now we are drawing this line, and this line is parallel to this line over here. That is why we have triple arrow here, parallel. And let's have another parallel line. We want to draw a parallel line to this line. So this is the parallel line. So that is why it's having double arrow. And we still have another parallel line. So we have another parallel line here. This line is parallel to this line. So it's going to have a single arrow. Now, having drawn a parallel line, we can use the knowledge of corresponding alternate angle, corresponding angle, opposite angle to fix some angles here. Now let's go ahead and do that. So we are starting with the exterior angles. Let's fix the exterior angles. Now, fixing the exterior angles, this A here will be the same thing as this angle. Don't forget corresponding angle occupying similar position. So this A here is formed by this line and this line. So this A here is formed by this same line and a line that is parallel to this line. So that is why we have A here. Now let's fix. Can we have another A? So we can still have another A here. So this is another A, corresponding angle. This line is parallel to this line, and we have this line here, which form this angle. So that is why we have this A here. So we are done with A. Let's move to B. For B, so we can have our B here. So corresponding angle. Are we done with B? We can also have another B here. So that is corresponding angle. Now let's fix C. To fix C, we can have our C here. We can also have our C here. So we have corresponding angle. These angles are equal. Now let's fix the interior angles using alternate opposite angles, alternate angle and corresponding angle. Let's start with A. If you look at this A here, you observe that we are going to have another A here, which is alternate. This angle is alternate to this angle. So that is why this A is the same. Now the same way, after we have fixed this, can we still fix A? Yes, we can fix this A. We have another A here. We have another A here and another A here. If you choose to fix this A first, this A is telling us that we have a corresponding angle A, and this A here is still the same thing as this A, which is what? Alternate angle, or we use opposite angle. This A is opposite to this angle, so we have A here. So now that we are done with A, let's quickly move to B, this small b. Now the first B we are going to fix is this B over here, which is alternate angle. This angle is alternate to this angle. Can we have another B? Yes, we can have another B. We have another B here, which is alternate angle. Can we have another B? Yes, we can have it. This angle here, which is what? Opposite angle. Now we are done with B. So can we move to C? Now let's find the C. The first one is here. So let's fix the second one. The second one will be here, which is what? Alternate. So we have angle here, we have angle here, the same. Now the next one will be where? It will be here, which is corresponding, or this C is also alternate to this C. Are we done finding C? No, not yet. We still have another C here, opposite angle. Now we have fixed all our angles. And what is the observation here? Let's visualize our diagram. Now, if you look at it very well, you observe that this capital letter C, which is exterior angle, plus this capital letter A, which is exterior angle, plus this capital letter B, which is exterior angle. When you add them up, you are going to get what? 360 degrees, sum of angles around the point. So, which means that if you add the exterior angles of a triangle together, you are going to get 360 degrees. That is first observation. The second observation is, let's pick any straight line and let's look at the angle that is formed on that straight line. So if you choose to pick this one, let's observe this one. You can see that on this straight line, small letter C is formed on it. Interior angles, small letter A is formed on it, and small letter B is formed on it. So all these angles lies on a straight line, and if you look at it, they are interior angles of this triangle. So which means that when you add angles that is formed on a straight line, you get 180 degree. So it now implies that sum of the interior angles of this triangle is equals to 180 degree. So that shows that we have proven the sum of interior angles of a triangle. We can see that is 180 degree. So if you choose to pick this straight line over here, just look at the angle that is formed on it, A, B, and C. If you choose to pick this straight line, A, B, and C, any straight line that you've picked, you will still get A, B, and C. Remember my video, I explained that sum of angles on a straight line is very vital for us when we are proving this in geometry. So here we go, we have angle on a straight line, sum of angle of a straight line, and we can see how the sum of interior angles of a triangle transcend to sum of angles on a straight line. Now instead of having this, let's look at another observation here. Now what is the observation? Let's pick each exterior angle and let's see what will happen. Let's start with A. If you pick this exterior angle, which is A here, you observe that A is still the same thing as C plus B. That is A. This A, you have it, is equals to what? C, this small letter C, which is interior angles, plus this small letter B. So let's observe another one again. Let's move to B. You can see that this B, capital letter B, is still the same thing as A plus C, small letter A and small letter C, which is interior angles. If you pick C over here, capital letter C, we see that we have small letter A and small letter B. The addition will give you this C. So it now means that when you pick any exterior angles of a triangle, it will be equals to when you add the opposite interior angles together, you get the exterior angles. So if you pick this A here, this A will be equals to other interior angles. When you add them together, you will get your A. For B, the same thing is applied, and for C, the same thing is applied. Finally, let's look at another observation again, which is we want to see something here. Now let's look at this straight line here for A. You can see that this capital letter A, which happens to be B and C, B plus C, this capital letter A, when you add it with this small letter A here, you get 180 degree, which is what? Sum of interior and exterior. Exterior and interior, you get 180. So let's write all this expression. We can see that exterior plus interior 180, exterior plus interior 180 here. We can also see that when you want to find the expression for the interior, is equals to what? 180 minus exterior, what we have here. The same thing with B, the same thing with C. And instead of having this, can't we just relate all these things and have an expression for triangle? Now that is what I want to do here. We know that A plus B plus C, which is interior angles, is equals to 180 degree. We have seen that. But instead of just putting 180 degree here, let's make an expression for A that we have here. Let's use the expression 180 minus capital letter A. What we have here. B, 180 minus capital letter B, what we have here. And C, 180 minus capital letter C, what we have here. So let's do away with our bracket. We are going to have this 180 degree minus A plus 180 degree minus B plus 180 degree minus C. So let's collect like terms. We have how many 180 here? We have 3 180 here. And we can bring all these alphabets together. Now we have A plus B plus C will give us 180 plus 180 plus 180 minus A minus B minus C. So we have how many 183? So instead of adding it, let's have 3 multiplied by 180. Or you can factorize this 3. Just bring out your 180. 180 divided by 180, 1 plus 1 plus 1, 3. 3 multiplied by 180. 180 in 3 places, 3 times 180. That is what we have here. Now for this guy, just factorize it. Factorize it by bringing out minus 1 or minus. So you are going to get A plus B plus C. When you factorize these 3 guys, you get this. Now observe something here. How many sides do we have for a triangle? We have 3 sides. So we now have 3 multiplied by 180. Let's just say this is a coincidence for this. So we have A plus B plus C we give us 3 multiplied by 180 degree. What is capital letter A plus B plus C that we have derived earlier on? It is 360 degree. We have it here. The goal is we want to have an expression instead of just having 180 degree. Let's go ahead and factorize this guy that we have here. We want to factorize this guy. Factorizing it, what are we going to get? Since we have 180 here, and we can also divide 360 by 180. So let's do that. Doing that, 180 will come outside. Divide 3 multiplied by 180 by 180. So we are going to be left with 3 minus 360 divided by 180. We are going to get 2. Now we have 180 open bracket 3 minus 2. Now what is 3 minus 2? 1. 1 times 180. 180. We still get back our 180 degree for A plus B plus C. So let's just say that since these 3 correspond to the number of sides this triangle is having, so let's just substitute this 3 with n. That's okay. For any polygon, okay, we can say that the formula to find the interior angle, sum of the interior angles will now be what? N, the number of sides minus 2. Let's just say this is coincidence. So we are going to use another polygon to verify this. So let's move on. Now, from this expression, we can say that the sum of the interior angles of a triangle is equals to 180 degree. We have verified that. We also see that sum of the exterior angles of a triangle is equals to 360 degree. We have verified that. And exterior angles of a triangle is equals to sum of the 2 other interior angles. We have seen that. I'm talking about this expression here that I've explained earlier on. Now we've seen that the sum of interior angles of a triangle is equals to 180 degree, and the sum of the exterior angles is equals to 360 degree. And we've also derived a formula which is the sum of interior angles of any polygon is equals to 180 degree open bracket n minus 2. And this formula still needs further proofs. Now in my subsequent video, I'm going to prove this same formula using another polygon. And if you haven't subscribed to this channel, kindly subscribe to this channel, like my video, share my video, comment your view about this video. And thank you. Subsequent video, we are going to address this formula properly. Thanks for watching and see you in the next video. Bye for now.